control the equipment in the plant. Operators in this control room will samples. Customers will use
Welcome to OMYA, the largest producer of fine ground calcium carbonate in the world. We're here at the Vermont plant to show you how we turn Vermont ore into calcium carbonate.
You may not realize it, but calcium carbonate is all around you. It's used in the paper industry to make paper whiter and brighter. It's used in plastics, from car parts to traffic cones, diapers, and lunch trays. Calcium carbonate is in many construction materials, like paint, caulk, duct tape, sealants, and joint compound. It's all around your house, in garden hoses and trash barrels, asphalt shingles, vinyl siding, PVC pipe, ceiling tiles, outlet boxes, carpet and carpet backing, vinyl windows, floor tiles, and cultured marble bathroom fixtures. Calcium carbonate is used extensively in food and pharmaceuticals, from cereal, pancake mix, crackers, and chewing gum, to antacids and calcium supplements. Where does calcium carbonate come from? It all starts with marble from our quarries. The quarry in Middlebury, Vermont was first discovered in the mid-1800s, but was closed soon after because the marble was not suitable for dimension stone, for buildings, statues, and memorials. It is, however, perfect for grinding into calcium carbonate, and OMYA took over and reopened the quarry in 1965. While most mining companies are only able to use about 15% of what they quarry, OMYA is able to use about 90% of what comes out of the ground. The rest is used as filler and construction material around Vermont. The rocks are taken from the quarry over to the rock crusher, where they are initially crushed into pieces that are approximately 15 inches in size. Eventually, they will end up to be 1/100th the width of a human hair. But first, they have to be taken to OMYA's processing plant in Florence, Vermont. As the trucks leave the quarry on their way to Florence, they are watched to virtually eliminate flying dust while on the road. At the processing plant, the rocks from the quarry are brought to stockpiles behind the plant and dumped. Loaders will then blend the marble from the quarries and place it into the plant feed hopper. The Cascade mill crushes the stone by tumbling it stone upon stone. By adding water, the resulting slurry can be easily pumped. By the time it gets out of the mill system, the particles are about half the width of a human hair. The slurry then goes to the flotation process, where flotation reagent in air is added to make bubbles that float out the schist, quartz, mica, and other impurities. While the impurities come off the top, the 99.5% pure calcium carbonate comes off the bottom of the tanks. At this point, the slurry is about 28% calcium carbonate by weight and 72% water. It is introduced to the ball mill, where ceramic media reduces slurry particle size so that 20 particles lined up is about the same width as a human hair. At the thickener, a 150-foot diameter tank, flocculant is added to increase the solids to 55% solids by weight and 45% water. Flocculant is a polymer that attracts calcium carbonate particles in the water. When enough have been attracted, the polymer and calcium carbonate sink to the bottom of the tank. All the water is recycled and used back in the Cascade mill. The slurry then goes through dewatering centrifuges to increase the solids to 72%. Storage tanks hold in-process slurry as well as finished product. 100 particles will make up the width of a human hair. Finished product is stored in 7 large tanks, each holding more than 400,000 gallons. Some slurries are dried to produce powder for the plastics and food industries. Exhaust gas from OMYA's two cogent electric generators, as well as fuel oil burners, produce gas to dry the slurry into fine powders that are then stored in silos near the finished product tanks. In order to maintain constant quality, PLCs, programmable logic controllers, control the equipment in the plant. Operators in this control room will monitor screens showing each process and make changes as required based on laboratory samples. The powders are packaged in 50-pound bags automatically. Operators will load reels of bags while other operators will use forklifts to move completed pallets to waiting trucks. The customer will often grind these bags right into their finished product. Other customers prefer to receive product in 1-ton semi-bulk bags. These bags are usually emptied, cleaned, and refilled. Most large customers prefer to receive finished products by truck and rail. OMYA continues to switch customers to rail whenever possible. Customers will use OMYA products for paper, plastic, paint, and food products. As new uses are found for high-performance powders, OMYA will be there, supplying consistent quality and service. Particle size so that 20 particles lined up is about the same width, meaning 5% solids by weight and 45% water. Flocculant is a polymer that attracts calcium carbonate particles in the water. When enough have been attracted, the polymer and calcium carbonate sink to the bottom of the tank. All the water is recycled and used back in the cascade mill. The slurry in the finished product tank. In order to maintain calcium quality, PLCs, programmable logic controllers, and heavy equipment in the plant. Operators must control the monitor screens showing each process and make changes as required based on laboratory samples. The powders are packaged in 50-pound bags automatically. Operators will load reels of bags while other operators will use forklifts to move completed pallets to waiting trucks. The customer will often grind these bags right into the finished product. Other customers prefer to receive products in 1-ton semi-bulk bags. These bags are usually empty, cleaned, and refilled. Most large customers prefer to receive finished products by truck and rail. OMYA continues to switch customers to rail whenever possible.
Welcome to OMYA, the largest producer of fine ground calcium carbonate in the world. We're here at the Vermont plant to show you how we turn Vermont ore into calcium carbonate.
You may not realize it, but calcium carbonate is all around you. It's used in the paper industry to make paper whiter and brighter. It's used in plastics from car parts to traffic.
construction type is known as town lattice. The other bridge you saw a couple of days ago was a Howe truss, but this is lattice construction. Has been to keep it in service has been extensively restored. Each of the heavy beams are bolted to each other. There's a splicer block right there. Some original wooden dowels there. Some bolts there. This style of construction was to use less expensive timbers to do the bridge. Smaller timber all bolted together in the lattice configuration made a strong bridge. Bolts are used at these splice joints, but wooden dowels are used at the other joints. This bridge also is a lattice work truss. Has not had as much rebuilding on it. Most of the timbers and beams look to be pretty weathered and pretty old. Same construction. All the joints are tied together with the wooden pegs. I don't see as many splices in this bridge. There is a couple splices right here with the bolts going through. But the other joints are all the hardwood pegs. Looks like we've got a little damage here. So a piece of farm equipment must hit it. It looks strange at this angle. It's not a very long bridge, but with the canted covering and the odd, can't really get to the side to where the stream is. This one is called Depot Bridge, not because the railroad went over it, but because of the depot that was down the lane by the tracks down there. The bridge is 120 feet long, and it is also lattice construction, and this end has had extensive repair with the roof, but the side beams all look to be original. This bridge must lean a little bit. It's got a couple outriggers added to it to support, so it must be leaning slightly. This has the looks like an older style planking versus the previous two bridges. We do have a few replacement trusses over here as part of the truss, but they're still put together with the wooden pegs, but it looks like they added a reinforcement here and here. This end of the bridge is definitely older. Of course, it could have been repaired back in the 30s or 40s, who knows. Since there's no sign on this bridge, I don't know the date. But I guess it's the same time period, 1840s or something. But there's no sign on this bridge. The bridge has been restored for walking only. The new highway bridge is over there. I will attempt to walk through. Typical lattice construction for the area. This one has had some whole windows put in it, which is, as I've read in a book, is a modern invention. The roof has some new timbers in it, and we got a new tie bar going across to help hold the bridge together. This is a wide bridge. I wonder if they could actually get two old wagons that pass through this bridge. In the beginning, of course, now with the modern reinforcements here to help keep the bridge square. Of course, it's obvious you can't drive through anymore, but at one time I'll bet you could get two wagons through here. I guess the best time to shoot this bridge would be in the fall, when the trees were less. Otter Creek is the name of the creek. And there's Jane's Primo limo and the tracks, but no traffic. No traffic. That's the train I shot from the museum. It just seems to be sitting there, like maybe they're done for the day. Right? Some kind of either industrial spurs or a junction here. Locomotive is sitting just beyond that car, and on a, it appears to be a track running out through there and another one going around the corner over there. No idea. Bridge number 5, Brandon, Vermont. The Sanderson Bridge. 132 feet long, 16 feet wide. Looks to be in good repair. Some of the original stone abutment. Looks like the bridge maybe has been raised on some new concrete blocks. Again, this is Otter Creek. Same lattice construction as I've seen previously. Of course, this one has an all-new metal roof instead of wood shakes. A few new timbers to keep it in good shape, to allow traffic to still use it. But 132 feet long. Our room was right here on the corner with our private balcony right there.
Picture, but there is a
Yours
picture,
is curly,
and there is a picture.
and mine with
Right, and ours.
Built in 1877, 139 feet long, completely restored in 1947. It's the only remaining wooden bridge in America of this design. It's a Pratt truss. It's an arched Pratt truss. With the iron bar cross trusses and the vertical timbers. Of course, it's a classic roof. Skylights, of course, are not original. Floor still has parallel timbers for the tire tread. Detail the blocks and iron plates for the bolts that run through the laminated timbers. The abutment has either been replaced or capped over with concrete. There's the original that would have been stone. Just a beautiful little river in central Vermont. Side. And now we see the far abutment is still stone. Good. This bridge is real interesting in that it has two arches. And I'm not sure if it's a Howe. I think it's a Howe truss with a second Howe truss. Which is a lot of traffic on this bridge. Reinforcement plates have been added. Details of the bolts for the iron trusses. They go vertical, which I believe then is a Howe truss. I don't know how long it is. This is the style that extends out the roof to protect the portal. There's some reinforcement work done around the pier, the original stone pier. The dam. We're standing next to the electrical building. And it would appear, based on this turbulence and the humming I hear coming from the building, that they are generating electricity here. I'm pretty sure it's in operation, because it's humming. And you can just hear it above the tone of the water. Based on what I read, these cutouts are not original. Somebody thought it would be cute to add them. The windows and cutouts are a modern invention based on what I read. Of course, this one now has a metal roof on it for protection. Focus on, you can see the curved trusses into and then up. You can see it right through there. Out of curving up. Inside, you can see it there. And then down through, and there it is. Going down to the abutment. Double pile truss is what I believe it is.